All right, today we're going to do a continuation of lesson 3.3 where we're solving equations that have variables on both sides. So in our last lesson, we looked at equations that had variables on either side and we solved them by still isolating the variable, getting x by itself. And we talked about how to do that. We had to get all of our variable parts to one side, all of our constants or non-variable parts to the other side, and then isolate the variable from there. So today we're going to continue doing that. We're going to continue to solve equations that have variables on both sides, but we're going to look at some special unique circumstances that can sometimes happen when we have variables on both sides. All right, now one more thing I want to say before we jump in any further is these situations that we're looking at today are unique circumstances, which means they don't happen very often. They only happen sometimes. And so the majority of the equations that you solve will still just have one number as the answer. So x equals a certain number. That is most frequently what will happen. These are just unique circumstances, but because they can happen, it's important for us to understand them. So let's take a look at this first example here. So it asks us to begin by rewriting the equation. So we've got 3 and then in parentheses 2x plus 1 equals 6x. So when I distribute that 3, I do 3 times 2x and 3 times 1. So that gives me 6x plus 3 equals 6x. Now, ignore this bold statement for just a minute. We're going to come back to that in just a moment. But let's think if we were solving this equation, what we would do next. And we talked about how we want to get our variable parts to the same side. So we typically just subtracted it from one side or the other. So if you subtract 6x from each side, because whatever I do to one side, I have to do to the other. What you should notice is on the left side, the 6x's cancel, and you have 3. On the right side, the 6x's cancel as well, so that would just be 0. And here's where we should see that we have a problem, because 0 does not equal 3. Okay, so let's actually go back and go to this part where we left off, where we had 6x plus 3 equals 6x. And let's think about this equation from here. So think about whatever x would be. On the left side, you would multiply by 6 and add 3. And on the right side, you would just multiply by 6. So do you understand that there's nothing that I can plug in here that's going to give me a true statement? Because the left side of the equation is always going to be 3 more than the right side, because on both sides you're multiplying by 6, but then on one side you're adding 3, and you're not doing that to the other side, and so that left side will always be 3 more no matter what you plug in for x. So the answer to this equation is actually that there is no solution, and those are the words that you need to write. You can't just stop and not say anything. You write no solution and box it because that's your answer. Okay, now how do you know that there's no solution? Well, one way is when you work it down, if you get, 3 equals 0, you know that that can't be true. 3 does not equal 0, so you've got a problem there, okay? The other way is when we go back to this step up here where we have the 6x plus 3 equals 6x, whenever you have identical variable parts that are on different sides of the equal sign, you've got a problem. And that's not, it could be that one's 6x and one's negative 6x. That's okay, but if they are exactly the same, so like here we have 6x and 6x on different sides of the equal sign, that's when there is no solution. Because if you're doing, if you're multiplying each side by 6, but then you're doing something to the other side that you're not doing to the other, it's not going to come out equal no matter what you plug in. And because there's no solution, there's obviously no check step to do because there's nothing to check because there's no answer. Now, the last thing I'll say about this is you've got to really be careful. Once people know that no solution is an option, oftentimes what happens is people, if the equation gets hard, will say that there's no solution, or if it's going to come out as a fraction, they say it's no solution. Those aren't no solution, okay? So these are unique circumstances. They don't happen often. The only time it happens is if you have identical variable parts on different sides of the equal sign. All right, let's jump down to the next example. And look at this one. So here, when I rewrite the equation, I've got 4, and then in parentheses, x plus 2 equals 4x plus 8. So I'm going to start by doing the multiplication and distributing that 4. So I've got to do 4 times x and 4 times 2. So this would be 4x plus 8 equals 4x plus 8. Now, obviously, you should notice something here, hopefully. And what you should notice is you have the exact same thing on both sides of your equal sign. So do you understand that whatever you plug in for x, it's always going to be a true statement, because if you multiply by 4 and add 8, and on the other side multiply by 4 and add 8, of course it's going to come out to be the same number. So whenever you have the exact same thing, all the parts are the same on both sides of the equal sign, the answer is all real numbers. And that's what you need to write for your solution. And I know it's a little weird to say all real numbers there. That is because we do have something called imaginary numbers. You don't need to worry about them right now, but the answer there is all real numbers. So here we are going to do a check step. In fact, you could do an infinite amount of check steps. I'm not going to make you do that, but we can plug in anything we want, because x could be anything. So you get to choose. So if I get to choose, I'm going to try to make this as easy for myself as possible. So I'm going to say, what if x equals 1? So here I would have 4, and then in parentheses, 1 plus 2 equals 4 times 1 plus 8. So on this left side, I do the parentheses first. On the other, I'm going to do the multiplication first. 4 times 3 is 12, and 4 plus 8 is also 12. So again, I ended up with a true statement, so I know that worked. Now, when you're doing your homework, that's all you have to do. You just need to plug in one number. I'm going to plug in another number just to show you what happens here. So you could also say that x is 2, because x can be anything. So if that's what I did, I would in the parentheses here have 2 plus 2, and then on the other side I have 4 times 2 plus 8. So this would be 4 times 4 over here and 8 plus 8 over here. So that's 16 equals 16. Now what you notice is you didn't necessarily end up with the same number. Here we got 12 equals 12. On the other one we got 16 equals 16, but they're both still true statements, and so that's fine. So everybody's check step might end slightly differently depending on what you plug in, but as long as you end with a true statement, you're fine. So you do need to do a check step. You can pick anything you want for x to plug in. So again, make it as easy for yourself as you want, but you do have to do a check step. All right, so now we're going to work out some more examples. And of these 6 examples, it could be that there's no solution, it could be that it's all real numbers, or it could be that the variable equals a number like we did in the past lesson. And in fact, when you do these problems and on your homework and stuff, that's what the majority of them are. The majority of them are going to have that the variable equals just one number. The no solution, the all real numbers are unique situations. So let's start with number 1. I'm going to start by distributing. So multiplying the 4 times the 3x and the 4 times 1, or probably easier to keep change and think about that as -1. So here I have 12x equals 12x plus -4. So then I'm going to subtract 12x, because again I'm trying to get my variable parts to the same side. And over here I have 0, and on the other side I have -4. Ooh, I can see I've got an issue here. 0 does not equal -4, and so this is no solution. I have to write the words no solution and box that, but I don't need to do a check step. Now, if some of you potentially up in this step here notice that there might be no solution because you saw maybe that you had that 12x on either side, and we talked about if you have the exact same variable part on opposite sides, then there's no solution. Because in this problem here, the right side is always going to be 4 less than the other side, because whatever x is, you'd multiply each side by 12, but on the left side you're doing nothing else, and on the right side you're subtracting 4, so that's always going to be 4 left. So again, you write no solution, and on that one you are done. All right, let's try number 2. All right, so my goal is to first get my variable parts to the same side. So you could either subtract 3n from both sides or subtract 5n from both sides. I'm going to go ahead and subtract 3n because I'd rather keep it positive if I can. That's just my preference. So over there they cancel. If it helps, keep change, change. So I have -6 equals 2n plus 20. So then I want to get the n by itself. So I'm going to subtract 20 from both sides. Since it's positive, to get rid of it, I subtract. If it helps you make that addition over there, I've got -26 equals 2n. So then I divide each side by 2, and n equals -13. So then I do need to do a check step because I do have a solution. So remember here, both times that I see n, I'm going to plug in -13. Then I'm going to, each side, I'm going to start by multiplying. -39 plus -6 is -45. -65 plus 20 is also -45. Again, remember how we talked about in the last lesson, this -45 doesn't show up anywhere else in the problem. That's okay as long as you get a true statement, which means you need to have the same number on each side. All right, let's go down to number 3. Okay, on number 3, I'm going to start by distributing. So on the left side, I'm doing 3 times 2n and 3 times 4, and I also need to distribute on the right side 2 times 3n and 2 times 6. So I've got 6n plus 12 equals 6n plus 12. All right, at that point, you should notice that you have the exact same thing on both sides, which means whatever n is, it's always going to be a true statement because on both sides you're multiplying by 6 and then adding 12. So my answer here is all real numbers, and that's what I need to write in box. And remember, when the solution is all real numbers, you do need to do a check step. You can pick whatever you want for your check step, so 0, 1, 2, 5, 10. If you want to plug in 215, you can. You're just making it harder for yourself than it needs to be. I oftentimes will pick 1. So in this problem, I would have, remember I go back to the original, so 3 and then in parentheses, 2 times 1 plus 4. On the other side, 2 and then in parentheses, 3 times 1, because whatever I picked n is, I got to keep it the same on both sides, plus 6. So in the parentheses, I do the multiplication first. Then I'm going to continue working in those parentheses and add. And then I can multiply and I get 18 equals 18. Again, that's a true statement, so I know it worked. But if you picked in something other than 1, your check step's going to end with different numbers, but it still should be a true statement. All right, let's do another one together. So number 4. This is one where people can be tempted to say there's no solution because they see that 2x on either side, but those are not exactly the same. One is 2x and one is -2x. And so this one is going to have a solution. It's only no solution if you have the exact same variable parts on opposite sides. So let's go ahead and start working on number 4. I can either subtract 2x from both sides or add 2x to both sides. So I'm going to go ahead and add 2x just to keep it positive if I can. So I've got 4x plus 7 on the left side, and on the right side I'm left with -13 because those cancel. Again, make sure you don't lose that negative sign. Make it addition, keep change, change if that helps you. All right, now my goal is to get x by itself. I have a 2-step problem at this point, so since I have a +7, to get rid of it I'm going to subtract 7. Then I've got 4x equals -20. Again, make it addition if that helps you. So I divide by 4 and I get x equals -5. All right, so again, this is one like from our past lesson where x is just one number, and that's what's going to happen quite often. So let's do a check step now. We go back to the beginning, and every time I see x, I'm going to make it -5. All right, so when we multiply, we've got -10 plus 7 equals positive 10 minus 13. So over here, that's negative 3 on the right side. If you want to make that plus negative, you can. You also get negative 3. So again, we ended up with a true statement, so we know we are correct. So right now, we're going to pause the video, and I would like you to try number 5 and 6 below. And then in just a moment, we'll play the video again, and you can check your answers. All right, so go ahead and check your answers. Notice on number 5, I started by distributing the 2. When I did that, I ended up with the exact same thing on both sides because I had 6x plus 2 equals 6x plus 2. And so that's all real numbers. And then in your check step, you do need to do a check step. You can plug in any number you want. I picked 1, so I ended up with 8 equals 8. If you had picked a different number, you would end up with a different number, but you still should get the same number on each side. Then looking at number 6, we distribute the 5. That gives us 10x plus 5 equals 10x. So when we subtract 10x, we end up with 5 equals 0, which is not true. 5 does not equal 0, and so there is no solution, and therefore no check step. So on the worksheet that you're going to do tonight, there will be potentially some that have no solution, some that are all real numbers, and also quite a few where the variable equals a number. So x equals this number or y equals that number. So there will definitely be some of those as well. All right, have a great day.